I'm live. Sorry, that was the message that YouTube just popped up to tell me that this is going live. So hopefully everybody is here, is healthy, safe, doing well, had a good weekend, got a little bit of fun. We're back for another week. Howdy. Back for another week of 115. So this week is going to be all about databases. Databases are really, really, really important. Now, just to make clear exactly how this week is going to be working, there is a weird thing with databases. When we're dealing with databases, as I talked about in the video, there is another language, sort of a third language, fourth language, whatever, third language I guess we're up to now, SQL, that we are totally going to not really work with. And the reason we're not going to work with it, we're going to talk about it a little bit. You should know the basics of the couple of commands. There's create table, select, insert. We're never really going to deal with delete. But I'm never going to ask you to write any SQL code other than perhaps in UB Infinite where you can look it up. Certainly not in next week's lab exam or on the final exam. We might ask you to look at SQL code that I've written and tell me how it works or something like that. That's a little bit of a different situation. But what I wanted to do today is just give you, in this live Q&A, give you a little bit of an overview of how databases work and how this database programming works. So, as always, if you have questions, please feel free to type them into the chat. I'm always willing to answer questions, certainly about this sort of material. Otherwise, I'll do my best, make my best guesses. So the database work that we're going to be doing in 115 is all using this SQLite 3 library, SQLite library. So there's a huge number of databases out there which use this SQL language. SQL stands for Structured Query Language, so I guess I don't need to say the language again. It's just a way of connecting databases and working with them. SQLite is very popular. It's relatively simple, but that's not a bad thing, particularly for what we're doing here. And part of the reason why it is somewhat popular is, in part, its simplicity means it's very, very fast. So, if you're dealing with huge data sets or anything like that, SQLite is probably not the database you want to work with. For anything more reasonable sized, anything like what we're doing here, it's fine. Now, in order to connect to a database, you need to be able to make a connection. You need a database connection. And so here I have a function. I just split this off into a function. I named the function, I don't know if you guys can read that. Yeah, you can. I'm going to turn off notifications because you guys don't need to see my fact that, hey, this is live. As you see my calendar also. Nothing interesting there. So we need to make that connection to a database. So what we do is we call SQLite3.connect, and that's a way to connect to whatever database we want. And now we're going to talk about a database as a thing, and it really is a thing, but it also is a file. We need to give it a file name. So we talked about this a little bit before. Generally speaking, text files end .txt. Their names end .txt. Generally speaking, CSV files end .csv. Generally speaking, database files end .db. There is no magic in that end of the name. There is no magic in how you do that. All that really does, that little bit of, that dot whatever really does, is in Windows, specifically Windows, it tells the computer, the Windows is looking for that little bit of information to tell it how it should treat that file. And then as human beings, we tend to rely on it to know how we should be looking at that file itself. You can technically name these files anything. Now in this connect call, right now I'm just using a file name, and then down here at the bottom, I'm going to open a file, music.db. I was looking for some data that we can use, and I actually found a database of the top 50 songs from the past several years. And for each song, it's got the name of the song and the artist, and I'm trying to remember exactly what it was. It's the, if I look down here, the length of the song, the number of beats per minute. So if you're trying to mix music, as you can imagine, I am the DJ master of all time, and I totally am mixing the beats, and I can't even pretend to try to do this. But if you're trying to mix music, you might want to pay attention to that, and then the length. So honestly, it was just a file I found. Hopefully a little bit of interesting stuff. So I want to create that. I have that CSV file. I want to dump it in a database, in part because this makes for hopefully something interesting, a way for you guys to sort of see the difference. So I'm going to use a file, music.db. Here what I'm doing is I'm using a variable that will be evaluated to music.db. I could also just do it directly. And so actually, let's just start with this. If I wanted to, I could just create the connection. And actually at the end, I'm going to close it just for simplicity. And so if I run this code, so I'm going to connect to my database, get that result as a connection. At the end, whenever you're done, you want to close your connection. It actually doesn't do anything. It's just good practice. So if I run this program, you can see not very much happens other than now I have this music.db file. So if we open it, right now, all I've done with this is literally created the file. You'll see it's boring. Nothing's happened yet. In order to really make this file interesting, we're going to have to do something more. So the connection, that's what's needed to do, frankly, three things. There's three things we do with that connection. One is we close it. A second one is typically we're going to call this commit function. And this commit function is needed. We haven't seen it before. It's needed because databases are designed to be very fast. It turns out that when you're working with any sort of data, the way that a computer accesses data really will change how long things take. So the thing to remember is the CPU, your processor, is incredibly fast. That's the thing that you hear about measured in gigahertz, right? So trillions of operations a second, billions of operations a second. So we can do, your CPU can do billions of operations a second, but that's true only if it has the data it needs. And so it has certain things on it called registers that it can access immediately, but it only has like maybe 64 of them. Most things that we use work in RAM, in your memory, your CPU. This is you have a 64 gigabytes of RAM. This isn't your hard drive, which isn't a hard drive anymore, but it isn't in your disk drive. It's in a different part. And RAM is much, much slower than your CPU. So if you think about the CPU, it's going to have a couple of different places it stores stuff. It has those registers. The easiest way I've ever heard explaining this is wanting a drink. Registers are like having a drink in your hand. On the one hand, very easy, almost instantaneous to take a drink. On the other hand, well, we don't have that many hands, right? You can't hold that much stuff. There is some other memory in your CPU. It's called cache, L1 cache, L2 cache, L3 cache. These get progressively bigger, but they get a little bit slower. So you go from your hand to like the refrigerator, the refrigerator you might have, the mini fridge you might have in your room, to the refrigerator, main refrigerator in the kitchen, to that L3 cache is going to be equivalent to sort of going to the bodega or the corner store, the 7-Eleven. You have to walk a little bit slower, but a lot more stuff. Going to RAM is like going to the grocery store. It is a lot more, right? There's a lot more selection of beverages. I'm actually able to. So the way that we usually explain this is honestly with beer, but since I imagine most of you are under 21, we'll say beverages, right? The grocery store has lots of choices of beverages, but it's a trek. It's going to take you some time. Compared to all that, anytime you go to a file, anytime you go to your hard drive, that's equivalent to walking to Germany. On the one hand, if you want a beverage, particularly an adult type beverage, you can't do wrong going to Germany. They're going to have plenty of that material for you. On the other hand, that's a really long walk, ignoring the ocean aspect and drowning. So in general, the computer really tries to avoid saving stuff to disk because it's really, really slow. Databases are going to take this to the extreme. The problem being at some point, we do need to make sure things get committed, that things actually get saved. And that's what that commit does. It tells the database, look, I don't know what you have going on. Make sure you save this. Make sure that this is going to actually be stored. So commit and close are two things. You'll see here, I'm doing them at the same time. We can actually call commit more often whenever we want. Realize there's going to be a slight performance penalty there. There's going to be some time to save it. On the other hand, not a big deal. The other big thing that we do with that connection is we get a cursor. And this cursor is really how we're going to do all of our work. That's really what we're going to do to be able to do any of those creation, insertion, updating, deletion, selecting sort of stuff. So in order to do anything, we're going to need a table. So the way a database file works, it organizes the data into tables. Each table is going to define some number of columns, however many you want, however many is appropriate for your data. Since our top 50 files have 4 pieces of data, our table is going to have 4 columns. You can have multiple tables in a file. We do this a fair bit. I'm just not going to because it's not that important for here. So the way that we create a table is we're going to have a cursor, and we use cursor's execute function. This is the way that we do any of the work with the data in a database. We call whatever the name of our cursor variable is .execute. And then we have to pass a string, a str, with whatever data we want. So here you can see I'm going to call create table if not exists. So this is the SQL command saying create this table unless it already exists. And this is sort of a safety mechanism. This is going to create a table. I named it Pandora because I was thinking of music. If that Pandora table already exists, database will just ignore this command. Otherwise, and so for this first time, it will create our table named Pandora. And then what we have to have is inside of parentheses, the names of the columns we want to have in our table. So this table is going to have 4 columns. The first thing is going to be the name, then the artist, then the number of beats per minute, and finally the length. Note, I'm not specifying types for any of these. Probably we can all figure out name and artist are going to be strings. BPM is going to be an int. Length is also an int. It's a number of seconds, I think. But you get the idea. So we can run this program now. And so all we're going to do is create that table, commit it, close it. And so if we do, now you can see, I'm going to open up this database file. And it is, first of all, big, relatively long, considering we have no data in it, and completely unreadable. You might be able to read the very first little bit here, right? It says SQLite format 3, and then good luck. This is the trick about databases. Another one of the things about databases. Every form of, every way that we've been storing data so far, which are text files, CSV files, are human readable. They've been designed for human beings to be able to read them and use them. And, this gets a little tricky with CSV files because there are some weird aspects of CSV file standards, like how you can get quotation marks into data and commas into data. But ignoring that, it's still basically human readable. A database says, you know what? Human beings are stupid. They're slow and they don't work the way that a computer works. We're going to say, screw it. They're on their own. A database file is not going to be human readable. They make no attempt for it to be human readable. You are never going to be able to really read a database file. That's not its goal. Its goal is to be optimized for the computer, to make sure the computer can read it as quickly as possible. So all of these things here where I'm showing it as a weird sort of question mark, you guys could connect to it too if you wanted and see what happens. It's not really that. What it is all of the data are stored in binary as zeros and ones. I mean, technically all data is stored in binary, but it's stored strictly in binary for the computer to be able to use this and manipulate this as quickly as possible. And so the characters that it's using, the values that it's using, just don't translate into ASCII, into the form that we all use. So one thing to remember is don't bother ever trying to open or look at a DB file. It will mean absolutely nothing to you. That's not the point. So having created our table, we now have space. And of course, I can run it again and it won't be a problem that I run that create statement again because it's just going to go through it. Now we can actually think about adding that music, taking all that music from the CSV file into our database. So here what I have is, we have the name of the file. I know it's top50.csv. I probably could make this a little fancier if I wanted, but honestly, I probably only run this once. So I'm going to do my with as to open my CSV file. Note one thing, we never use with as or even an open call for a database. We just get that connection. I'm going to create I don't even know. I wrote this a little while ago, and at some point I had a reason for creating that data list. I don't know why. I'm going to create my CSV reader. That's important. And the first thing I'm going to do here, just to show you, is comment all this out. We can create that CSV reader, and you'll see I'm using a special function here, type. This just prints out this just returns what type some piece of data has. The thing I wanted to point out about this is we're going to be able to use, and we have been using, the CSV reader in our loops, right? As our loop collection here. But it's not a list. It's not a tuple. It's not a string or a sequence. It is a CSV reader. Just because we're using data in our loops does not mean it's particularly valuable. Now, we can actually get the data from that top 50 file, right? We get each row. If we look, we've got the name of the song, the artist, Shawn Mendes, yay. I don't actually know who that is. I'll be honest with you. The number of beats, the length, and so one thing we might want to do is let's just think about what's going on. So let's, first thing first, uncomment these, right? One thing to pay attention to, one thing to remember. We can look at what each value is and what its type is when we read it in. So I'm assigning it to variables. I'm honestly assigning it to variables because it's just easier to understand, easier to work with for me. So let's just look at what type we read everything in as a CSV file. Hopefully you all remember this, but one thing you'll see is each one of these is read in as a string, type str in Python speak. And that's because a CSV file, right? It's human readable. It's text. Texts are strings. So if we want to be able to do something with it, I returned none inside my loop, honestly, just so we could see that result. What I have to do is work with it. So here I've got actually, that's not the one I want. I want this one, right? So one thing that we can do with databases is databases, in part because they don't just use normal sorts of stuff. We're going to do an insert statement, the way that we add data, insert into, then the name of our table, Pandora. Then we have to have another keyword, values. And then we have parentheses, and we have to put the data that we want to add to our database. I will be honest with you, I don't actually ever use this version of the insert statement. So this is the unsafe version, the non-tuple version of an insert statement. I never ever use it. We'll talk about why, and I'll show you why more a little bit on Wednesday, and then we'll really get into it and discuss this in Friday's lecture, so a little bit of foreshadowing. But I know the basic idea. So here's what I've done is I've taken my thing and I said, okay, the first thing I want to provide is the name, then the artist. One nice thing about a database, not everything has to be text. Remember that database file is stored in more or less unreadable fashion. So we can actually see what's going on. We can add to it, and we can actually have it store numbers, ints, or floats, or booleans, whatever we want. It will take care of all that for us, so we don't have to constantly do typecasts. So for this first time, what I did was I said, let's insert into there, and I want the name, the artist, and then I want beats per minute and length as numbers. So any idea if this is going to work? Anyone have an idea? Give you all a couple seconds. Okay, don't see any responses jumping out. Usually that's when people start to respond. Okay, so since it doesn't seem like any of you have an idea, easy way to solve this, let's run it. Let's see what happens. When I run it, it's going to crash. It crashes. And the reason why we can sort of see here, if you haven't learned yet, you can actually use this information. It tells you what line it's on. So it's saying that it actually shows you this traceback. So the first thing here is the line in your main code, whatever was being executed. So that's line 39, right? We called import music. And then it says the bottom line, there can be more if we have more function calls between them, is line 33. So this is the line that actually crashed. And it says can only concatenate stir to stir, and it has not int. The thing to remember when we call cur.execute is we're going to run this, we're calling a function, we're giving it an argument, which is the SQL to execute. That SQL is, and you might notice it start here, it's a string. It's a single string. And so right now, what we are trying to do is we're trying to create this string. I'm actually going to, just so we can look at it. It's going to move that into its own thing, and we'll execute that. It's not going to work because we're trying to take this int and make it into a string. So we can't do that. So let's just change this up. We'll make this into, we'll get rid of those ints, right? BPM and length, because they were read from a CSV file, are by definition strings. So that's not a problem. Okay. And we can print out what we're going to execute. So now I can run my program. I've gotten rid of that problem. And it's still giving me an error, saying an error near Mendes. So the problem is that when we call execute this string, right, this is the string that we're going to execute, it needs to know what are string data and what is not string data. By default, it's going to assume things are numbers. When we want something to be a string, we usually need to specify this inside of quotation marks. And that is in the string that we actually execute. It needs to be in quotation marks. So this is actually a lot like, if you remember JSON, how JSON works. Same basic idea. So what I'm going to do is I'm going to change my double quotation marks to single quotation marks because it actually wants double quotes. So if I add the double quotes around artist, you can see that I was curious. I sort of knew the answer, but I just added around Shawn Mendes because that's where it was giving me an error. But of course, Señorita here, even though it doesn't have a space, it's still a string. And so for that one, I also need double quotes. I can keep that. So now if I run this, you're going to see that we can insert lots of different things. Occurs to me that some of these titles are not necessarily the most appropriate titles, but apparently season 3 of 13 Reasons Why gets really dark and lonely. So you can see all sorts of music. Everything that's in quotes is a string. So the title of this one is, Bad Guy. That apparently I didn't realize it had Justin Bieber in it. And then the name of the artist, Billie Eilish, is in quotes. That's going to be a single string. But note that the numbers do not have to be. If text isn't in quotes, then by definition, we're going to assume it's a number. And so we can execute all of this. And when we do that, I'm going to get rid of the print. If we want, we can rerun this. Don't need to import music anymore. And we can read the table. Now, when we read the table, I'm actually going to do this. What I'm going to do first is to get results out of the database, we need to use a select statement. So again, we use our cursor, select star from Pandora, and we're going to get back this response. And so what I'm going to do first is just print out the type of that response and then just end so we can see very clearly what that response is. And what you can see is it decided it didn't want to work. There we go. It got confused. When I run this, you can see that this response is of type cursor. It doesn't make sense. Don't worry about the details too much. The bigger thing is that when we call a select statement, we're going to get a response. That's great. We can use this response much the same way that we can use a CSV reader in a loop. But that response is not a list. If we want to respond with a list, what we need to do is create a list and add each row to our list. So what I'm going to do is I can show you this. I'm going to show you what we're going to get. So we'll do this just once for the first time. So what I'm going to do is I'm going to go into this. And so I've got for row in, and that's my response variable right there. And so what I'm going to do is I'm going to say, let's go through each row that we return. For that row, for this first time, I just want to print out, what the type of the row is. So you can sort of see what that row is going to be. And then what the type of each location is. Note that the way that we're going to use this, it's sort of a giveaway of what we're going to get. What that select statement returns is some sort of collection. And we're using index 0, index 1, index 2, and index 3 to access each of those columns. So we have to know how this table is set up in order to work. So if I run this, you can see that the first thing that we're going to return is Señorita by Shawn Mendes. It's got 117 beats per minute, 191 seconds long. And note that what it's returning is each row is going to be a tuple. It's basically like a list. The difference between a tuple and a list is a tuple is immutable. I cannot assign something to row 0 or row at index 1, something like that. It's going to stay the same. But given that, so on the one hand, that is the downside. On the upside, note that data that we stored as an int is still an int. The database has no problem separating strings from ints, from floats, from everything else. If we look at the database file, still lots of stuff at the beginning. You can sort of see that there's a table here. There's a little bit of something there. If you look, you can see that there is some data here that probably makes sense, such as Summer Days featuring Macklemore. Wow, someone had bad taste. Featuring Macklemore and Patrick Stump of Fall Out Boy, right? You can see that this is a string, but then there's some weird stuff here. So again, the database is really written in order to be optimized for reading by the computer. Lots of different pieces of data. Don't try to make too much sense of it or the order, because even though you can see some of these strings, you can't really edit this file directly, and it's not going to be particularly readable. But for the computer, perfectly readable. So if we want to create a list of our results, what we could do is run this, take our select statement, get our response, loop through our response, add each one of those tuples that we got as a result to our accumulator, and then return our accumulator. And if we do that, then what we're going to see is we get this list of tuples, right? Each thing that we added there is now in this list, and now we could use it like a list as we have so far. So when we get data from our table, we can then add it to a list. We have to add it to a list if we want to be able to use it as a list later on. This is especially important if we want to use it in a web application. So most semesters, admittedly not this one, we would have 2 projects. And in the second project, you would end up having to write some sort of database-driven web application. In that situation, you need to remember to add data to a list, and we'll have to do this in our music app because, right, a tuple or a SQLite 3.cursor type doesn't translate to JSON. A list does. So now we have something that we could use in JSON. If we wanted to make it really fancy, what we could do is create a list with all of our rows. Right, and what this will do is just rather than having tuples everywhere, now we have a list of lists, which is just a little bit nicer. It doesn't really matter. Either way would work, right? We can use a tuple just like a list. They're basically the same thing other than how we can actually use them. So this is an easy way to do things, but suppose that rather than reading the music table and getting all of the music, we wanted to get only the really fast pieces of music. So only the ones where, and this is a way that we can edit our select statement to limit what gets returned. So where the beats per minute is greater than 150. So we only want the sort of faster paced music. If that would help if I typed in greater than correctly. So now when I run this, note that we don't get all of the rows, but we only get, let's see, Boyfriend by Ariana Grande, which has 190 beats per minute. Ransom by Lil Tecca, 180. Bad Bunny's song, I don't know this music. I'm sorry. I'm old. I would say, Lizzo, I know her. Truth Hurts, I know that one. 158. Antisocial, 152. I know who Ed Sheeran is. This is why I think, I was going to say, if you haven't watched last Friday's video, the introductory video, for those of you who did, you got to meet my daughter. I need her around so she can tell me about all this music. I don't know these things. But this is one nice thing that databases get us that we can't do with like a CSV file, right? We don't have to do any of this checking. We're just going to type that in. We could even add things together. We can say, I want the beats per minute to be greater than 150. And shall we say we'll say the length should be less than 200. So you can see that the Robart, I don't know how you pronounce it. The Nicky Jam song goes for 202 seconds. A couple of these others do too. So if we run this, now you can see we can actually get small, narrower things. We could also do, we can use equality checks. Note it only uses a single equal sign. Suppose we want all of the Lizzo music. Apparently there's only one Lizzo song in this, one Lizzo song in that list, but we can do all sorts of different checks and the database is going to take care of it for us. Note it comes back almost immediately. So any questions so far? Any questions on all this? Okay, I don't see any questions. So one last thing just to let you know of, one sort of thing to be careful about when you do this work, when you're using a database. Suppose that we've got this music list right here. Right now, I'm going to go back to selecting everything. Right, so you can see the top 50 has 50 rows in it. No problem. When I read that table, print out the length, I get 50. If I re-add that import music function, so I call import music, right? That reads in the top 50.csv file and calls insert onto it. What's going to happen is when I read it in this second time, note that the length of that result gets up to 100. The database is still being run by a computer. Computers still have an IQ of 0. Yes, I just added literally the exact same data as I had before. There's no difference here in the data. That's, the computer, obviously that seems like a weird thing to do. Nobody would ever do that. The computer doesn't know any different. If we look, our file is going to have more of everything because now it's got 2 copies of each piece of music. You can see you need to calm down. I saw Taylor Swift's name twice. it's going to do whatever you tell it to. If you tell it to add another copy, that's fine. If I tell it to do it again, and that'll go up to 150, it's going to do exactly what you tell it to. So if you ask it to insert, even after you've added those values, it'll do that again. So hopefully this gives you a basic idea of how you can run these insert commands, the create table command, select statement command, how when you get a select, you want to add everything to a list. Any questions about that? Don't see any. Any other questions about databases in general? Anything you want me to go over right now? Okay, since there aren't any questions, and this is really what I had to show you for today. Thank you all very much for watching this. Hopefully this helps you as you work in UB Infinite, as you get ready for this week's lab activity is just on custom sorting. You will not need any of this. Next week, however, is lab exam number 4. For lab exam number 4, there will be, I believe, a database question. I actually don't remember. I'm sure there'll be at least one database question. It's one of 3 topics in module 4. So you can be pretty sure that you're going to need to know at least a little bit of this. So hopefully this prepares you a little bit for it. We will be talking more about databases as we go on. In lecture on Wednesday, we're going to talk about how we can change our music rating app to take advantage of databases. We're going to do that a couple different ways, talk about how that implementation worked in this live Q&A. And then Friday, we'll talk about how not to get your database application hacked, like seems to happen every day to people. So thank you all very much. Hopefully this was helpful. If you have any questions, I will have office hours in about 15 minutes on WebEx. I think in Zoom, the TAs have office hours. Otherwise, thank you all, and I will talk to you on Wednesday. Talk to you later.